All right, second page. Which of these numbers is a natural number? This is in the set n. And the natural numbers are things like 1, 2, 3, etc. You keep counting. So 9 is definitely a natural number. So 9 is. 0 is not a natural number. 0 is in the set whole numbers. So the whole numbers include 0 and all of the naturals. -1, come over here. -1 is a negative number, and negative numbers are in the integers, which include all of the naturals and the wholes plus the negatives. And last, 1.8 repeating. This one is 1 and 8/9 as a fraction. This is a rational number. Rational numbers are Q, anything you can write with one integer over another, as long as that one is not 0. It can't be 0. So all of these numbers in the list are rational. They're all in the set Q. That's not what they're asking us. 3 of them are integers. That's not what they're asking us. 2 of them are whole numbers. That's not what they're asking us. They're asking us about the natural numbers, and that's going to be just 9. Question 8. Which of these numbers is rational? What ones can you write as a fraction? So let's take a look. These are all roots. Root 4 over 169. 4, I think we should recognize from our list of perfect squares, is 2 squared. So as I say, root 4 over 169. That's 2 squared. And we know we can take this 2 squared and throw it on the outside, right? 169 you may or may not have memorized from your list of perfect squares, but you got a calculator. That's 13 squared. So we can take that pair of 13s and throw it on the bottom here. 213. 2/13 is a nice, pretty fraction. So the root of 4 over 169 is 2/13, and that's a nice rational number. That's the first one I checked. That's good. So that's going to be D. If we check the other numbers, root 48. Root 48, if we do 48 is 2 times 24, or 2 times 2 times 12. 2 times 2 times 2 times 2 times 6, I think. And that still leaves us with a root 6. No, that's just not a 6, that'll be a 3. Let me check. 2 times 2 times 2 times 2 times 3. 48. Yeah, that's a 3. Okay. So that lets us with this group of 2's we can get out, that one we can get out, that looking good. But this 3 that's left behind there is no good. So I can write a 2 and a 2 on the outside. I leave a 3 on the inside. I could say 4 root 3, and that's just not good enough to be a rational number. That does not have a nice repeating decimal, or it's not just a nice integer. It is not terminating. It doesn't meet any of the criteria to be rational. So, too bad. If we check the cube root of -16, the cube root of -16, if we take the factors of 16, we can divide it by 2. Equals the cube root of 2 times 8, right? And 8 is 2 times 2 times 2. So if I'm looking for a group of 3 I can pull out, that's great. That's 2 times the cube root of 2. But the cube root of 2, that's not rational. So, can't do it. If I check the last one, the cube root of 8.1, not the cube root, square root of 8.1. If I take the square root of 8.1, if I'm looking for the factors of 8.1, well, there's not some nice factors. There's just not nice factors. If it was the square root of 81, I'd be in business, right? Square root of 81 is 9. If it was the square root of 81, I could say that's the root of 9 times 9. And I take these out, and I just write 9, and I'd be happy. I pick it. But it's not. It's the square root of 8.1. And the square root of 8.1 isn't just 0.9. It's closer to 3. It's like 2.8 and some junk. So 2.846, etc. So I can't choose that one either. We knew it from the first one. I tested it worked. But it's always worthwhile to check at least one other option, so you know you're not fooling yourself. Number 9 says, which of these roots lies between 3 and 4? So just evaluate these with a calculator. I think that's the fastest way to do. So if we take the cube root of 28, that's 3 and a bit. 3.03659, it says on my calculator. Well, 88972, whatever. That's between 3 and 4. Looks good. I'll choose C. Just quickly, though, we'll check the other ones. The cube root of negative 172. If I take 172 and I take the cube root, I get negative 5.56, etc. That's too big, bigger than 4. If I take the square root of 17, the square root of 17 is 4.123, etc. That's too big, bigger than 4. And if I check that last one, cube root of negative 118. 118 cube root is negative 4.904, etc. Which again, too big. Well, it's actually too small. These negative ones are actually too small. They're on the other side of the 0. But no matter what, they're not between 3 and 4. So for that question, just evaluate all of the things with your calculator. Pick the one that's between 3 and 4. And also be careful about the negative sign. It's positive 3 and positive 4 they're asking us about. Number 10, what's the smallest number? So again, just evaluate them. If I take the root of 14, that should be 3 and a bit. If I take the cube root of 30, that's 3.01 something. If I take the fourth root of 100, that's 3.16 and a bit. And if I take the cube root of 75, that's 4.2 and a bit. So out of these, just which one is the smallest, least smallest? That's this one, cube root of 30. So I choose B. Next, write root 98 in simplest form. Why not? That means factor 98. So 98 is, I can divide by 2 and get 49. I can divide 49 by 7 and 7. So root 98 is the same as root of 2 times 7 times 7. These 7, that's a pair, I can take them out. That's the same as 7 root 2. And I can double check on the calculator to make sure that 7 root 2 has the same value. And I recommend that you do that every time because it's very easy to make a small mistake here or there. But it's also easy to catch it on the calculator. Last question on this page. Write the cube root of 1372 in simplest form. So in this case, I'm factoring 1372, which means I'll need space to do that. 1372, I can divide by 2, and I'll get 686. 686 is even again. I can divide by 2 and get 340. Hey, I remember 343 from before. That was 7 times 7 times 7, I think. Divide by 7 is 49. Yep. Divide 7, 49. 7 times 7. So my prime factors are 2, 2, 7, 7, and 7. So I can say the cube root of 1372 is the same as the cube root of 2 times 2 times 7 times 7 times 7. This is a cube root, so I'm looking for a group of 3. I've got these 3 7s. Great, I can break that 7 out. And I can write the 7 in the front. And those poor 2's stay inside. And my final answer would have to be 7 times the cube root of 4. And again, for all of this, double check on your calculator that the answer you think you've got is actually the same decimal value as what it should be. It's an easy check, might as well do it. Okay, start a new video for the next